Today I'll be presenting on meter control method for emergency solar management. My name is Nigel Wilmot. I'm the Senior Standards and Technology Engineer at Western Power, working within the Distribution Grid Strategy and Standards team at Western Power. I help develop the standards and requirements for connecting of inverter bed generation technologies to the network. Western Power acknowledges the traditional owners of the land on which we meet, Wadjuk people, and recognises their continuing connection to the land, water and community. We also pay respects to their elders, past, present and emerging. Today I'll present an overview of the requirements for meter control. In particular, I'm going to talk about updates to industry standards and requirements, changes to the application process that come in 14th of February in 2022. Then we're going to talk about the site evaluation criteria for meter control method. Also, what are AMI meters? Then we'll be talking about how we can use those AMI meters to provide the control required in emergency solar management, and then for the requirements for commissioning and testing. And finally, I'll be covering key takeaways for the day. WA's energy needs are evolving. 1 in 3 households now have rooftop solar, and this is increasing, resulting in more solar energy flowing into the network. The state government is driving transformation of energy sector to include greater renewables while ensuring continued safe, reliable and affordable supply of electricity to the community. In response to the load on the network, we need to control these systems, and as previously mentioned, there's two methods. There's cloud control through Synergy, and then there's Western Power's control through the meters. Today I'll be focusing on the meter control methods and all that you need to know. There has been 2 standards recently published in December. The first one was the basic inverter generator connection technical requirements. This provides everything you need for connecting a embedded generator, an inverter energy system typically, to a standard connection service on the Western Power network. In addition to that, we've also updated the distribution customer connection requirements, and these provide the installation arrangements, wiring sample examples for you to work out how to connect and arrange your installations. The embedded generation application process is being updated. It's essentially a 5-step process. This will enable emergency solar management to be implemented, and also this change will occur on the 14th of February. The first step of the 5 steps is site evaluation. Solar providers and installers will need to undertake a site assessment, evaluate optimal emergency solar management control method, whether it's cloud or meter control. Once you've done that, you complete the electricity retailer solar application and you confirm the control method you've selected there. Then you can go on to the Western Power network approval, similar to what's been done previously. A lot of information will be pre-populated from the electricity retailer information. Finally, you'll need to install and register your system. And finally, a notification will be sent to applicant that the application approval is complete. So let's have a look what you need to do for site evaluation. The first thing we're looking at is meter control method. Okay, before anything, the control method, either cloud control or meter control, should be identified through a site inspection by a licensed electrician. So if you're not choosing a suitable inverter for cloud control, or the internet's not available with the customer, you need to then work out whether or not your site's suitable for meter control. What type of connection? As with all solar systems, the connection type is important. Is it single-phase connection or a three-phase connection? Now, for example, if it's a three-phase connection, it will require additional relay to disconnect the EG system. This provides issues along the lines of space requirements for the switchboard, rearrangement of circuits potentially to fit things in, and that's got to be considered. And similarly with these things, you need to add in a new main switch, which will control the source from the auxiliary terminal of the meter and providing isolate. So there's additional pole on the main switch. So is there space? Can you modify the switchboard without extensive cost? So look, important, perform a site inspection. And look, meter control should only be selected where cloud control is not suitable or available. And look, go to the distribution customer connection requirements to see how the wiring arrangements look, and I'll go through them shortly. So first we will have a look where meter control is not suitable, and this is to guide you through the small number of instances where meter control is not feasible. It's possible to do it in all these situations, but the cost for doing it may be more than the solar system, some examples. And hence the need for a site evaluation. So the first lot of systems are unfeasible older style switchboards. You've got apartment blocks and unit developments. Then there's something that we're calling remote switchboard, where you have a meter close to the boundary and the embedded generator connected to another switchboard down the track. And what is unfeasible or old style switchboards? Why are these not suitable? These sites pose an installation issue even for your standard embedded generation system, standard inverter installations. So they will also provide more issues if you want to include meter control, as additional space and wiring components will need to be fitted. Quite often, this may result in additional upgrades to the current standards once work has commenced. The next area that will be problematic and should be able to easily be assessed from a site evaluation is apartment blocks and unit developments. These sites often have meters that are grouped, and that causes difficulties, particularly around needing additional space. If they're older styles meters, then the new meters may not fit in. In some of these apartment blocks, you'll have what's called a plug-in meter. These plug-in meters are not suitable for meter control, as they're not set up for that. And look, as with all these things, if you've got group meters, you've got group main switch to provide wiring to the meter in the switchboard, you would need to do a whole of site disconnection to make the changes to the main switchboard. Quite often in these sites, you'll need a new switchboard to replace the existing switchboard. Now, remote switchboards. What is a remote switchboard? This is where an inverter system is connected to a subboard remote from the main switchboard with the Western Power meter. And to get the control signal from the meter to the remote switchboard, you'll need to put an additional cable for the auxiliary function control and wire it all the way back to the subboard. And this provides a switch signal to the inverter. Now, common scenarios are rural properties, and that's the bottom picture there. Meter box on the boundary next to the pillar or the overhead incoming line. Then a long underground and sometimes overhead connection to the house, which to add another cable will be very difficult, but is possible. Would potentially be very costly as well. In strata developments, this is again, you may have all your meters in the main switchboard on the proper boundary closest to Western Power's connection service, then having to run the next cable. You may need to dig up ground and those sort of things. Similar long metro driveways. You may be lucky in that you can easily trench down the driveway, but in some instances that won't be possible. You may also find that you come across a site which has a boundary fence. May look like a normal metro installation, but has a boundary fence, and they've mounted the meter box on that fence, and then the subboard on the house. There's also the situation where you've got a meter box main switch on the side of the house, but then the house subboard with all the circuit breakers and switches are inside or in the garage. That's quite feasible to do, but some of these other examples I've given aren't. So I've talked a bit about AMI meters. AMI, advanced metering infrastructure, are an important step to unlocking future energy opportunities for WA households. It's an electronic metering device which has an embedded communication device. Western Power uses this for safety monitoring of the connection point. It fits within a standard metering panel, and it's connected to the Western Power's private and secure radio mesh network, which we use for communications. Being a private network, it gives a high level of cyber security, and there's no personal information transmitted across this network. Communication network coverage is fairly extensive in the Western Power network at the moment. Mostly the metro network is covered, and we're expanding it all the time with full coverage in the next few years. This enables remote reads of the meter by Western Power, but also it can be used to remotely control the solar systems. The single phase and three phase meters are shown here, and very similar to what the current metering are in Western Power. We talked about auxiliary control terminals. This auxiliary function will be used to provide Western Power the control for emergency solar management via wiring of the inverter system to this terminal at the meter. AMI meter with auxiliary control is an additional active terminal that is able to be switched remotely. The meter's auxiliary terminal can switch the connected circuit. We communicate that command, that switching command, over the secure communications network and enabling the disconnection of solar generation to the grid. A three-phase meter has similar functionality, however it has an auxiliary function terminal associated with the one phase of the three phase. You can see here the second element in the switching of that element, which will be used for controlling the solar system. Not that you need to know this, but we've also shown you the load control terminal where our metering technicians will connect the cable left by the installers to the meter to enable meter control on a single phase and then on a three phase. Let's talk about the methods control now. Now for these slides, there's schematic diagrams for each of the scenarios that we've considered, and these are all contained in the distribution customer connection requirements. As I go through these slides, I'll be pausing for a short period to enable people to look at each slide and note down questions and possibly put them in the chat on the side. Now, there's been the update stands, which I talked about earlier back in December. Now, the one you need to look at is the distribution customer connection requirements document. And these diagrams I'm showing comes from there. And you can download that from our industry site under manuals, guides and standards. With meter control methods, we use two meter control methods to control embedded generation systems. There's what we're terming direct control, and essentially the meter is connected to the inverter system via the auxiliary terminal and the additional pole on the main switch. When we send a controlling signal across our comms network to the meter, the switch will open and will disconnect or reconnect the inverter. Then the second method for meter control is indirect control. In this method, the same mechanism is used, but it's connected through a discrete main switch pole, but it's connected to a coil or driver circuit of a contactor. The switching element of the contactor is in series with the main switch inverter supply and the inverter. When we send the controlling signal to the meter to disconnect or reconnect power to the contactor, the contacts and therefore the inverter. This is probably a good time to reiterate that a site inspection by an electrician to identify the appropriate control method, either cloud or meter control, is really important. Now, meter control should be selected where cloud control is not suitable or available. For installation arrangements, refer to distribution customer connection requirements. So the first, probably the most simplest method is a single phase system with direct control. On this slide, we have, and in the requirements, we've used a blue line to indicate the additional wiring and components associated with the control method. Essentially, the only difference with this is instead of connecting the main switch inverter supply, MSIS, to the same bus as the main switch output, we are connecting via a separate wire an additional main switch pole to the auxiliary terminal of the meter. So you can see this is an additional wire, additional pole on the main switch, connecting to the main switch inverter supply in the meter. Let's move on to the next example. In this example, you can see that we've added in an export limiting device. This export limiting device can measure the gross load, and so it still enables you to direct control the single phase inverter with the meter directly. So you still have an additional pole on the main switch, export limiting device communicating the load to the inverter, and then meter directly switching the inverter on and off when required. Now let's look at the single phase indirect control. Some export limiting devices need to measure net load and generation, and in that situation, we need to use indirect control. So essentially you install the single phase inverter system the same way as you've done previously. However, between the main switch inverter supply and the inverter isolator or the inverter, you install a single pole contactor, which is normally open, and a control cable with fuse protecting the coils of the contactor to the additional pole of the main switch. Western power will terminate into the meter. Then we've talked about remote switchboards. It is possible to connect direct control to a remote switchboard, and we show you what would be required. Again, an additional pole on the main switch at the main switchboard. You need circuit protection for the cable leaving the switchboard to the incoming control and protection on the remote switchboard downstream of the main switchboard with the PV system connected to that. Again, additional main switch in that subboard for the direct control methodology. In almost all situations, a three-phase connection point will need to be using indirect control. It's similar to the single-phase indirect control, but the differences are you'll need a 4-pole main switch circuit breaker to provide that additional pole on the main switch for the auxiliary terminal. You'll always be using a contactor, but it'll be 3-phase contactor to switch the 3-phase inverter, and you'll need fuse to protect the control cable to the contactor. Now the next example is, again, indirect control, but all with an export limiting device. Essentially the same arrangement. However, you have export limiting device measuring net generation, net load at the 3 poles of the main switch. The other pole is sending the disconnect signal to the contactor to disconnect or reconnect the inverter. Three-phase remote switchboard with indirect control. Again, this is where it is feasible to do this. As we mentioned earlier, there's a lot of places where this will not be feasible. As you can see, you still 4-pole main switch on the main switchboard. You'll need to add a 4-pole main switch on the subboard to comply with 3000 requirements. The control cable doesn't need to have a lot of current carrying capability because the coil circuit will only draw a small amount of current, but you'll need to ensure it's suitable for the situation, suitable for not too much voltage loss to the contactor to make sure it works properly. Again, similar, you've got the 3-pole controlling the inverter downstream of the main switch inverter supply. So now we will move on to commissioning and testing requirements. With meter control, there's some additional steps that need to be considered. So obviously, to complete the installation, you'll need to energize the EG system and make sure it's safe and to be able to submit your completion notice. You'll need to confirm functionality and system compliance. If you're monitoring off the internet, you'll need to set up an internet access. You can complete the installation by temporarily connecting the additional pole to the other side of the main switch. Then after you've done your completion notice and registered the system, the meter will be replaced. And by Western Power will replace the meter using the additional pole of the main switch to the auxiliary meter terminal using that cable that has been left by the installer. So the site preparation for meter control, how should you leave it? Well, after you've finished your commissioning and testing, you should isolate and tag out this embedded generation system, and that's done by the system installer. We want the supply control cable intended for connection to the AMI meter from the site main switch additional pole. We want that connected to the consumer main switch and unconnected to the AMI meter. The cable will be labelled, tagged, and made safe for termination AMI meter. You'll need to put an insulating connector on the end of it to make sure it's safe and doesn't touch live parts. And it's just going to be left behind the meter boundary panel. In all this, it's critical that the installer does not move the metering panel, as moving it will expose the electrical worker to an energized electrical installation. A video will be now played and will continue to be available for training later. Now, what's important to take away from this presentation today? Well, the connection requirements are changing on 14th of February, so download your copy of the basic EG generator standard and review that. Look at what's changing, see how it's going to affect your installation applications from the 14th of February. If you don't choose an inverter which is capable of cloud control or cloud control isn't available, it is really important to have a site evaluation if you're going to need to use the meter control method. Look at the manuals, look at the distribution customer connection requirements so that you're familiar with what is required for emergency solar management. All this documentation is on our website. And finally, it's important that to keep abreast of changes in the solar industry and electrical industry connecting to Western Power Network, sign up for the industry updates, stay informed, and get all our important announcements. That concludes the presentation. Thank you for your time today.